on the southern coastline of Korea. A new dream of crossing the deep ocean is coming true. Global vision in the 21st century. The Dream Ocean Way linking Busan to Gojae Island is nearing completion. The 8.2-kilometer long Busan-Gojae fixed link project consists of an immersed tunnel to be placed at an unprecedented depth of 48 meters, a 2-pylon cable-stayed bridge, and a 3-pylon cable-stayed bridge. The immersed tunnel is made up of 18 elements that are each 180 meters long. Total length of the tunnel is 3.7 kilometers. It will be the world's longest and deepest immersed roadway tunnel. The cable-stayed bridges have curved diamond-shaped pylons, which is a world first. The Busan-Gojae fixed link will be completed in 2010. Built for optimization and a safe design with long-term vision, will open a new era for linking the oceans of the world. The link has not used the conventional way of boring a tunnel in hard ground under the sea. It has employed the immersed tunnel method. All elements are precast on land, floated to the site, immersed onto a prepared seabed foundation, connected to each other by water pressure, and then covered by protection works. There is a 500-meter-long, 200-meter-wide dry dock at the Anjung Industrial Complex in Tongyeong City, Gyeongnam Province, for fabrication of the immersed tunnel elements. Elements are concrete structures that make up the tunnel, built at an onshore yard. Each tunnel element prefabricated on land at the Anjung complex is a complete concrete structure 180 meters long. They are the world's longest elements and weigh from 45,000 to 50,000 tons each. The tunnel element is made up of 8 segments, which are each constructed in one continuous concrete casting with traveling forms specially manufactured for the project. This prevents early age cracking, and steam heating is applied for additional quality control.
To get a watertight and durable tunnel, it is essential to build it in high-quality concrete, free from through-going defects. This is because the concrete is the primary barrier against water ingress, and it needs to make tight connection with the joints. The concrete also protects the rebar from corrosion from seawater chlorides.
After fabrication of the tunnel elements, they are floated and transported to the site. First, the dock is flooded with seawater to float the elements. At the same time, water ballast tanks in the elements are partially filled through a pipeline to prevent irregular movements of the element during flooding. After flooding the dock, the elements float with their top surfaces approximately 30 centimeters above the water level. Buoyancy of the elements is controlled by adjusting the water inside the ballast tanks. The elements are towed out to a temporary mooring area to await transportation to the immersion site. Ground conditions between Gaduk Island to Jeongjuk Island, where the elements will be placed, consist of soft clay 20 meters in average depth. This needs to be properly prepared in advance of the immersion. First, dredging works are done to provide a seabed trench for the elements. Second, deep cement mixing and sand compaction piles are constructed for soil improvement of the soft ground conditions. Finally, a gravel bedding layer is constructed to make the foundation flat. In parallel with preparation at the immersion site at the mooring area, all equipment and facilities for immersion are installed, and the element is prepared for transportation by tugboats to the immersion site at Gaduk Island. In order to accurately predict the marine conditions during transportation, a local weather forecasting system has been installed at the site, the first of its kind in Korea. A 5-day period with waves less than 0.4 meters high is needed during transportation, immersion, connection, and stabilization of each tunnel element. Once this 5-day window is confirmed by the weather forecasting system, a decision to go for transportation and immersion can be made. Once the element arrives at the immersion site, it is connected to pre-installed anchors and wires to stabilize it against waves and the current. After increasing the weight of the element by increasing water in the internal ballast tanks, it is immersed under the control of a positioning system and adjusted by the connecting wires to its correct location. The new element is placed about 50 centimeters behind the previously installed element. After that, final connection work is prepared. At first, pulling jacks are installed between the previous element and the new one. Then, the tunnel is slightly lifted by a steel frame structure installed outside the element, called an external positioning system, to reduce friction force between the gravel bed and the underside of the element. Once the friction force is reduced, the element can be pulled to the connection surface of the previous element by pulling jacks. When connected, the rubber joint installed at the end of the new element is first compressed to seal a space between temporary bulkheads to prevent ingress of seawater. After confirming the first connection, entrapped seawater between the bulkheads is dewatered by opening the immersion chamber valve on the bulkhead of the previous element. While dewatering, the water pressure of the connection side decreases, and that of the rear side of the new element keeps constant. Therefore, this difference of water pressure between the two sides can eventually compress the rubber joints. After connection, the final correct positioning is done by the EPS. Then second rubber joints, omega seals, are installed inside the elements. Backfill and rock protection are installed to protect the tunnel against external impact, such as from a sinking ship, ship collision, and falling or dragging anchors. After dewatering and dismantling of the ballast tanks, ballast concrete is cast inside the tunnels to prevent uplift and movement of the tunnel, and all the construction activities are finalized by doing pavement works. Two cable-stayed bridges will be constructed connecting Busan to Goje. A 2-pylon cable-stayed bridge from Jeongju Island to Jo Island, and a 3-pylon cable-stayed bridge from Jo Island to Goje, which is the first of its kind in Korea. A cable-stayed bridge comprises pylons for supporting the bridge, a steel girder frame for the concrete roadway, and cables to connect the girders to the pylons. The pylon design doesn't follow the conventional H shape of the existing cable-stayed bridges in Korea, but has a curved diamond shape, which optimizes structural efficiency. Cofferdams, generally as big as a football field, are difficult to construct and can cause environmental issues in the ocean. The Busan Goje fixed link has applied the precast caisson method, which is recognized as the most optimal method for marine construction. It is the first use of prefabricated caissons for sea-crossing bridges in Korea. Prefabrication of the structural works ensures high-quality control and construction safety. All parts for the bridges except the pylons are fabricated on land and transported by sea to the location. Concrete caisson foundations of the cable-stayed bridges are fabricated at the pre-casting yard. The heaviest caisson weighs 9,600 tons. It is partially prepared onshore and transferred by using a 3,000-ton marine crane to be completed offshore. Two lower parts of the caisson, which weigh 2,600 tons, are fabricated at the yard. Each of them is moved to the offshore yard by a marine crane. The two lower parts are connected offshore by building the upper part of the caisson. Caisson transportation has utilized the natural buoyancy of the open-celled grid structures. By floating them, the weight is shared between the water and the 3,000-ton crane. Hence, the caisson can be moved by the marine crane onto a floating dock for the 35-kilometer-long journey to the site. The ground has been excavated to reach a sound soil layer to support the caisson foundation. 3 precast landing pads are placed on the formation layer, ready to receive the caisson. The caissons are sunk using water ballast, which is later replaced by rock ballast once they are in place. Once a caisson is positioned on the landing pads, grouting is carried out to fill the gap between its underside and the seabed. Grout materials, a mixture of cement, gravel, etc. Trench flaps made of a geotextile membrane are installed at the edge of the caisson to stop cement washout. The flap is enough to stop the current and debris and makes for still water conditions below the caisson. This helps the grout to fill all voids between the underside of the caisson and the seabed. This is called the underwater grouting method. Large-scale tests were done to ensure that the caisson grouting would work. Apart from the grouting method, the Busan Gojee fixed-link project has introduced a whole range of new construction technologies, such as the precast construction method to fabricate, transport, and install the caissons. This opens a new chapter for sea-crossing bridge construction techniques in Korea. After completion of the caissons, pylons are made from in-situ concrete, and then cables are installed from the pylon to decks. The bridges have unique and beautifully curved diamond-shaped pylons. This unique shape requires fine and accurate construction methods. Apart from aesthetic aspects, the diamond-shaped pylons also have the structural advantage of minimizing the size of the caisson and of improving aerodynamic stability of the cable-stayed bridge. Once a pylon is constructed, the deck and cables are installed. A floating crane lifts the pier table onto the pylon crossbeam, and it is then fixed to the pylon with cables. Derrick cranes are then installed on the deck to lift the girder frames and concrete deck panels. A derrick crane lifts each 12-meter-long steel girder frame into position. It is then fixed to the previously installed steelwork by bolted connections and to the pylon with inclined cables. Once the frame is connected, the derrick crane lifts and installs 6 precast concrete panels. This superstructure segment erection work is carried out alternately from the center of one pylon to both outer sides and is completed at the middle of the main span after connecting the key segment by bolting. Roadway pavement, lighting standards, and safety barriers are then installed as finishing works. A wide range of advanced civil engineering technology has been applied to the bridges to cope with the marine situation, such as the floating deck system. This means the deck is supported by cables, not by bearings on the pylon crossbeams. This is a newly developed method to improve structural efficiency and safety. The approach bridges have also used precast construction methods for caissons and pier shafts to minimize works in the open sea. Full-span 90-meter lengths of prefabricated deck sections are erected by a floating crane, ensuring high-quality control and ease of constructability. The Busan Gojee fixed-link project has employed a high-tech durability design to meet more than 100 years of service life. The concrete used has high durability against chloride penetration compared to normal concrete. The cable-stayed bridges of the Busan Gojee fixed link are environmentally friendly structures that have minimized marine working problems by using advanced construction technology. They will harmonize with the beautiful skyline of the neighboring islands and be a landmark on the southern coastline. The Busan Gojee fixed link project has prepared well for various risk factors that may occur under and over the open sea.
부산-거제간 연결도로 침매 터널은 높은 수압, 지진, 선박 충돌 등의 극한 상황에서도 그 기능을 유지할 수 있도록 설계되었습니다. 또한 진보된 개념의 지방 계량 공법을 적용해서 장기적인 침하에 대비하였고, 터널 내부에서 발생할 수 있는 차량 화재에 대해서 터널과 이용객들이 안전할 수 있도록 계획하였습니다.
The southern coastline of Korea has a large volume of seagoing traffic, including container ships, gas and oil tankers. Militarily, it is an important and strategic area. The overall design of the Busan-Goje Fixed Link project considered loadings from impact and sinking of a 50,000-ton vessel sailing to a neighboring port. A particular safety measure is that the minimum clearance from sea level to the top of the tunnel's rock protection is more than 20 meters, which is well in excess of the 15-meter maximum draft of a 50,000-ton vessel. Even if a large vessel deviates from the navigation channel, it can be controlled by the Emergency Observatory Center with an advanced warning system so that all possible risks are well prepared for. In the event of a fire, the immersed tunnel structure is designed to be safe at a temperature of 1300 degrees Celsius. And emergency accesses are provided every 90 meters along the tunnel to give drivers a safe evacuation route through the central service gallery. In addition, an intelligent traffic system and supervisory control and data acquisition system will cover the whole line of the project to prevent human casualties and to provide early warning of fire. The Busan-Goje Fixed Link was also designed to safely withstand seismic load, so no traffic problems are expected, even after a strong earthquake event. Furthermore, the entrance level at the tunnel portals is designed to be high enough to be above the effect of flooding from large waves, storms, and global warming.
The bridge has been designed for the most severe cases you can think about, for earthquakes, wind, typhoons, ship impact. You have a ship channel, you have ships going underneath the bridge, and of course big waves. Those things are all considered in the design to make the bridge as safe as any road in Korea traveling on in its final state.
In 2010, when the project opens, the journey time from Busan to Goje Island will be reduced from 3 hours 30 minutes to 40 minutes. And it will form a U-shaped connection by the Daejeon-Tongyang Expressway and Daegu-Busan Expressway, which will be a main artery for international logistics.
チンマイトンネルは海底トンネルを建設する方法の一種ですから、例えば韓国と日本の間、あるいは韓国と中国の間の海底トンネルを建設するのに参考になるでしょう。したがって我々は今後ともこの工法が韓国の役に立つよう願っています。
The Busan-Goje Fixed Link is recognized as a significant international project in heavy marine construction that has provided the opportunity for Korea to increase its construction expertise to the global standard. The Busan-Goje Fixed Link will become a main artery to link logistic routes in Northeast Asia and is a result of Daewoo's continuous innovation, challenges, and passion.
프루지오